Okay, dear students, welcome to this video. This video is very important. So now we are moving into a topic named calorimetry, which is basically the subpart of your topic 3.1 for the old syllabus and B.1 in the new syllabus. So in calorimetry, what is happening? We talk about sensible heating, latent heat, Q is equal to MC delta T, and everything. So let's see what is there in the calorimetry now. So there are two things. Like we already know what is heat and what is internal energy now. So let us say there is a liquid here, or there is a substance that you have, and you are giving some heat to it. So heat Q is given to it. So when this heat is given to it, it can result in two different things. Like what is going to happen? So point number one is that the temperature of this body is going to rise. And point number two is the body might go undergo a phase change, and we would be talking about that. So these two type of heats, and they are named differently. So the first heat is called sensible heating, and the second one is known as latent heating or the latent heat. Sensible heat, as the name suggests, it is like you see these, like your books are not using these terminologies, sensible heating, calorimetry. That is not written in your books. But this is what they are. They are not using the terms, but this is what they are. So sensible heating, as the name suggests, it is sensible. When you provide heat to a body, what do you expect? You expect that the temperature rise will be seen. You say that yes, I'm sure the temperature will be rising. So if you provide heat to the body and the temperature rises, that heat is known as sensible heat. Clearly, there is a formula for it, which is Q is equal to mc delta T. And this C is known as specific heat. Specific heat. So specific heat is like how much heat will be required to raise the temperature of 1 kg of the substance by 1 degree Celsius or by 1 degree. So you want to increase the temperature by 1 degree for 1 kg of substance, and what is the heat that was required? That is known as specific heat. So this is specific heat. So Q is equal to mc delta T. Delta T is the change in temperature that will be reported. M is the mass that you have chosen here, and Q is the heat that has to be given to it if you want to rise the temperature by delta T. So this is a simple thing, and this is sensible heating. Another type of heating is called latent heat. Latent heat is involving a phase change. So you already know how many types of phases are there, like solid, liquid, and gas. So when we are heating it, it should melt. So it is like known as melting. So there is a phase change named melting, and then there is something called freezing, the reverse process. Then there is something called boiling, in which you are changing from liquid to gas, and then there is condensation, which is when you are changing the phase from gas to liquid. That is condensation. Okay, and accordingly, there is something called sublimation. Sublimation. Sublimation when a solid is directly converted into gas. Okay, and then there is a reverse process also. uh, i I don't know what it is known as, declination or something. I'm not sure about this word, but because in my country, in my books, we use a different name for it. We call it hoarfrost. So hoarfrost is a process when gas is directly converted into solid. Okay, so this is what is there. So I'm not sure about what was the name here. So you can please check your books, and you can also mention that in the comment section. Okay, dear students. So this is what is phase change. So when we talking about this phase change, we talk about the latent heat. Now, what is latent heat? Let's see. Latent is a word taken from Latin language, and latent means hidden. Okay, hidden. So why hidden? Because we are providing heat to the body, but the temperature, the corresponding rise in temperature is not taking place. So where is this heat going? We don't know. That is why it is known as hidden heat, isn't it? Like latent heat. So latent heat means that we are indeed providing heat to the body, but the corresponding rise in temperature is not seen. So what is actually happening to the substance? Phase change is coming into the picture. So you are providing heat to it, solid is converting it to liquid. You provide heat to the liquid, liquid is converting into gas. But the temperature change is not there. It means that if we take example of water and ice, so ice at 0 degrees C is converted into water or liquid at 0 degrees C. The temperature is not changing, but still you are breaking the bonds. Here it was ice, solid, the structure was there. You have given some heat to it so that the structure breaks and the molecules become relatively free to move, and hence the solid is converted into liquid. So you are indeed heating it, you are giving some heat to it, no doubt about it. But this heat is used not to increase the temperature or the kinetic energy, but to break the bonds, which clearly means that you are now messing around with potential energy. So in the latent heat, only potential energy is increasing, the kinetic energy is not changing. Kinetic energy remains the same. It means that the molecules, like the vibrational kinetic energy, whatever it was for the ice molecules, the same will be the kinetic energy for the liquid also, provided the temperature does not change. So temperature change is having a direct relation with kinetic energy. Okay, and in the case of latent heat, it is only and only potential energy which is increasing. Similarly, if you are still like you move from like I'm having water here now, maintaining it at 100 degrees centigrade, I want to convert it into steam, and it is converted into steam at 100 degrees C. If this conversion has taken place, again some heat has to be given to it. And if this heat will be given to the liquid, again, phase change is involved. The temperature is not changing. So the kinetic energy of the water molecules at 100 degree will be equal to the kinetic energy of the steam at 100 degrees centigrade. There is no change in kinetic energy, but the potential energy definitely here. There was some value of potential energy which was negative. You gave some heat to it, and now the potential energy becomes zero. So in the case of ideal gas, the potential energy is equal to zero. Steam is almost treated as ideal gas. Okay, so for steam, the potential energy becomes zero. Only energy left with the steam is kinetic energy. Although this kinetic energy is much more than the total energy of the liquid or the total energy of the solid, because you have to give some latent heat to convert liquid into gas. Okay, so this is what is phase change. Now, this latent heat is also having a formula. Like here it was Q is equal to mc delta T. Here there is no delta T, but it is m into L. So latent heat is defined as the heat required to convert the phase of 1 kg of liquid, to convert 1 kg of substance from one phase to another phase. So what is the heat required? That is known as latent heat. Okay, and although these values for the latent heat as well as for the specific heat, that will be given to you in your question, or that should be given in the data booklet also, you need not to remember it. Okay, but I believe it is, if I'm not wrong, oh yeah, the specific heat I can tell you, this is 4200 joule per kg Kelvin for increase of 1 Kelvin, or you can say 4.2 kilojoules per kg Kelvin. One is the same thing. I'm coming to the latent heat now. One moment. Okay. Latent heat of two types now. Obviously, there are two different cases. So the first case is fusion. So I can call it like the latent heat of fusion. So latent heat of fusion is, you write it as LF. So latent heat of fusion is the latent heat that has to be given to convert the phase from solid to liquid for 1 kg substance. That is the latent heat. In the case of water, if I remember it exactly, it is this 333 kilojoule per kg, if I'm not wrong. Please confirm the data from the data booklet and know that's okay. And the latent heat, there is a second type of latent heat also, and that is the latent heat of vaporization. So this is written as LV, and this vaporization is again like too high, again kilojoule per kg. It is 2250 kilojoule per kg in the case of water. This everything is in the case of water that I'm telling you. This specific heat is for liquid. For ice, it will be different. For gases, the specific heat will be different, but I don't remember them, so I will not be writing it here. So, anyways, this data will be given to you in the question. So, these are the values. Another very important point that you can note here is you can clearly see the specific heat of water. If you want to actually increase the temperature or decrease the temperature for that sake, that is just 4.2 kilojoule per kg, but the latent heat of fusion is 333, and the latent heat of vaporization is 2200, which is I don't know how many times more than the specific heat of water. Specific heat of water is also assumed to be one of the highest among all the normal substances. Like the water can be used to decrease the temperature of the surroundings. Like you can keep on giving heat to the water, but water refuses to increase its temperature. It is like that. That is why we sprinkle water on hot days. Like usually we take bath because we want to lose our heat. The water takes up the heat, but the temperature is not increasing for the water, so it just takes up the heat, it absorbs it, and the heat is gone. Got it? So that is a marvelous feature of water. But you can clearly see if you want to convert it into like steam or something, if you want to convert the phase, a lot more energy is required. And that is why owning a steamer in your bathroom or owning a steam bathhouse or something, that is really a big deal because that will be consuming a lot of energy. Okay, dear students, so this is it for the calorimetry, but this is not all. In the next video, I would be doing some questions in which we would be talking about transfer of heat from hotter body to the colder bodies and all. So the topic has just started, couple of more videos, and then topic B1 or the topic 3.1 will be over. All the best. Bye. Thanks for watching.